In the video introducing simple harmonic motion, we said that the force needed to stretch or compress the spring or elastic material by some length is proportional to that length. The more you stretch the material, the more force is required. So it takes twice as much force to stretch a spring twice as far. The spring applies a force to oppose the stretch called the restoring force. When you release the applied force, the restoring force brings the spring back to its original length. The relationship between the restoring force and the displacement is called Hooke's law and is given by the formula F subscript r being equal to kx. In this formula, k is called the spring constant. It is a measure of the elastic material's stiffness or its tendency to resist a change in its length when a force is applied to it. The larger the spring constant, the harder it is to stretch. For dimensional analysis, the spring constant has a unit of newtons per meter. Because the restoring force opposes any applied force to the spring, it acts in the opposite direction to the applied force, and Hooke's law is often written with a negative sign to indicate this. But care should be taken when using the negative sign so as not to interpret the restoring force as being a negative value depending on the coordinate system used. The negative sign purely indicates an opposition to the stretch. Consider the following spring. When we apply a force to the spring, as indicated by the red arrow representing the applied force vector, the spring exerts a force back equal to the applied force in the opposite direction as indicated by the blue arrow. So for this spring, a force of 20 newtons stretches it by 0.1 meters. If we apply a force of 40 newtons, the spring stretches by 0.2 meters. An applied force of 60 newtons stretches the spring by 0.3 meters. A force of 80 newtons stretches the spring by 0.4 meters. And a force of 100 newtons stretches the spring by 0.5 meters. On the force versus displacement graph, we can see that the relationship between the force and the stretch or the displacement is a straight line. The gradient of this line is the spring constant. So from the graph, what is the spring constant for this particular spring? Now, how far will the spring stretch if a force of 50 newtons is applied to it? We can also compress the spring by applying a force to the right. The spring will apply a restoring force to the left towards its equilibrium position. The spring constant is the same regardless of whether the spring is stretched or compressed. But there is a limit to when the restoring force works. This limit is called the elastic limit. If you stretch a spring beyond its elastic limit, it will permanently deform and will not spring back to its original length. In summary, when a spring or elastic material is stretched, it tries to restore itself to its original length by applying an internal restoring force. The amount of stretch is determined by the restoring force and the spring constant. This relationship is called Hooke's law.